So, what's the big deal with blockchain? Why does everybody keep calling it unbreakable? Well, believe it or not, it's not some crazy complex magic. It's actually a really elegant system that's built on one single, very simple idea. Let's break down how this chain of digital pages creates a whole new kind of trust.
Okay, to really get our heads around this, let's just forget all the tech jargon for a minute. The best way to start is with a really simple analogy. Just think of a block as, well, a page in a notebook. That's it. That's our starting point.
All right, so we're going to start with that one single piece, that digital notebook page. Because if you can really understand this one thing, you'll see exactly how the entire security system is built, right from the ground up.
And it works just like a real notebook, right? When you fill up a page with notes, you start a new one. It's the same deal here. Once a page, our block, is full of data and transactions, it's considered done, and you just start a new one. This creates a really simple chronological record. Page after page, one after the other. Pretty straightforward so far.
Okay, but what's actually on one of these digital pages? Let's, peel back the cover and take a look at what key pieces of information really make up a single block.
So every block has a few key ingredients. First, you've got the transactions. That's basically the notes themselves on the page. Then you have the timestamp, which is just the date and time it was all written down. And then you have this thing called the previous hash. And you want to think of this like a unique, unforgeable fingerprint of the last page. And trust me, this last one, this is the one that changes everything.
All right, first up, transactions. This is the meat and potatoes, right? The actual content. For something like Bitcoin, it's just a list of payments. Who sent what to whom? But it could be anything, like a record of who owns a piece of digital art, or even the deed to a house. And get this, a single one of these pages can hold thousands of these records all bundled up together.
Next up is the timestamp, and this is super important. It's like digitally stamping the exact date and time on the page the very second it's finished. So you don't just have proof of what happened, you have unchangeable proof of exactly when it happened, locking it into a specific moment in history.
And now for the main event, the previous hash. Okay, this is where it all starts to get really cool. Remember that fingerprint idea? This is it. It's a one-of-a-kind, totally unique digital fingerprint of the page that came right before it. This little piece of data, this is the secret sauce. It's the glue that turns all these separate pages into a super secure chain.
So what's the result of all this? Well, once a block is finished and added to the chain, it's sealed. Everything inside it, all those transactions, that timestamp, that fingerprint of the last block, it is all locked in, for good. It's designed to be permanent.
But, and this is a big but, this brings us to a huge problem. A single page, a single block, all on its own, no matter how perfectly it's put together, is actually not secure at all. It has a fundamental weakness. Yeah, just think about it. A single block is like a lonely sticky note. Sure, it's got information on it, but what's stopping someone from just rewriting it? Or crumpling it up and throwing it away? Or just replacing it with a totally new one? Nothing. There's no anchor holding it accountable.
And that's the key difference right there. An isolated record, it's totally vulnerable, it's super easy to mess with, and nobody would ever know. But a chained record, that's a whole different ballgame. Its security comes from being mathematically tied to every single thing that came before it.
So, how do we solve that lonely sticky note problem? Simple. We don't leave it lonely. We forge these individual pages into a chain. And that chain, that's where the incredible security comes from.
Remember that previous hash we talked about? That digital fingerprint? Well, this is its whole job. It's the magic ingredient. It's like an unbreakable staple that physically attaches a new page to the one right before it, creating this incredibly strong, verifiable link.
There's a great quote that just nails this idea. It says, because every block contains the hash of the block before it, each block is mathematically dependent on its entire history. Do you see what that means? It's not just connected to the last page. It's connected to every page, all the way back to the beginning.
So picture this, right? Block 500 has the fingerprint of block 499 inside of it. And block 499, it has the fingerprint of 498. And that goes on and on and on. An unbroken chain of fingerprints, all the way back to the very first block ever created, the one they call the Genesis block.
Okay, so we've built this incredibly strong chain. Now for the ultimate test. What actually happens if someone tries to go back in time and secretly change something?
Let's get specific. Let's say a hacker wants to alter a single transaction way back in the chain's history.
Maybe in block 200. What do you think happens next? Well, what happens is a massive, catastrophic domino effect. The second they change even one tiny detail in block 200, bam, its digital fingerprint, its hash, instantly changes. Now, block 201 is looking for the old fingerprint, but it's not there anymore. So that link, it shatters. And it doesn't stop, because block 201 is now broken. It breaks the link to block 202, which breaks 203, and so on. A huge cascade of broken links all the way to the present day. And guess what? The entire network sees this happen instantly.
And that is the whole point. This immediate, obvious, loud failure means you can't change the past in secret. Trying to tamper with the blockchain isn't like quietly erasing a pencil mark. It's like setting off a giant alarm that everyone on the network can see and hear. It makes cheating practically impossible.
So let's just boil this all down. We have a page of data, which we call a block. Each page has a fingerprint of the one before it, the previous hash. This creates a mathematical chain that's locked in chronological order. And if you try to mess with just one link, the entire rest of the chain visibly shatters. And that simple, almost beautiful idea is the whole secret behind blockchain's integrity.
And that leaves us with one last, really big question to think about. It's one thing to understand the how, but the more important thing is the so what. If we now have a way to create a shared record, a shared history that nobody can secretly change, what does that actually make possible for the future?